Hello and welcome to Math with Mrs. Becker. Today in pre-calculus we are going to start chapter 5 by looking at radicals and how we can actually write those as rational exponents and vice versa. So when we are looking at nth roots, what that means is they might be a cubic root, a fourth root, a fifth root. It does not always have to be a square root. Okay, you can write it from a radical into a rational exponent. Remember, a rational number, fancy way of saying it's a fraction. So what this means is, like, if I have the square root of x, the square root of x is really the same thing as x to the 1/2 power. A square root really has an unwritten index. That's the little number right here. It has an unwritten index of 2. But let's say I have the cubic root of x. The x would stay the same. Whatever number is right here, that is the denominator of the fraction. So what if I have the fifth root of x? That would be x to the 1/5 power. So all of these things are actually equal value. It's just an alternate way of writing them, okay? When you are going ahead and simplifying, what you need to realize is that when you have an nth root and there's more than one term underneath, that nth root does apply to whatever is underneath the radical, okay? Just like if you have an exponent outside of a set of parentheses, that exponent goes to everything that's in parentheses, okay? Now, hopefully, as we go through some of these operations, I'm hoping that it kind of triggers a little bit of a memory for you. Some of these things we have looked at in like Algebra 2, some of them maybe even towards the end of Algebra 1, okay? So the first thing, if you have two radicals and you want to multiply them together, you can, as long as you have the same type of radical, meaning this is a square root and this is a square root. So I can multiply them. And the way you do that is you multiply the radicands together. The radicand is the number that goes underneath. So I can take 8 times 12, which is 96, and I can condense it so it's just one square root. So you can go from 2 into 1, you multiply the two numbers. Now what we have to do is simplify it if we can, because 96, you guys, 96 is not perfect. So if I go ahead and I take 96 divided by 2, I get 48. Well, 48 I can break down into 6 times 8. 6 I can break down into 2 times 3. 8 I can go 2 times 4. 4, I can go 2 times 2. And I know we've done a lot of simplifying radicals, so hopefully you're pretty comfortable with this. I can cross off 2 2's, that allows me to write a 2. I can cross off 2 2's, that allows me to write a 2. Remember, when you can cross two things off that are the same, you get to write it on the outside once. This 3 could not be crossed off. This 2 could not be crossed off. So they are stuck underneath. I have a 3 and a 2 left. Now you have to make it so you only have one number on the outside and one number on the inside. The way that you do that is you find the product. I had 2 numbers on the outside, so I multiply them. 2 times 2 is 4. I have 2 numbers on the inside, so I multiply them. 3 times 2 is 6. So our first example, the square root of 8 times the square root of 12 can be condensed into the square root of 96, which is equal to 4 square roots of 6. Okay. Next rule, if you are ever subtracting radicals, you have to have the same radicand. Remember, that's the number underneath. So here, it's easy to look and say, hey, 12 and 75, they don't match. We got to move on. However, these are not simplified. 12 can be broken down into 2 times 6. 6 can be broken down into 2 times 3. So I can cross off 2 2's. That allows me to write 1 2 on the outside. 3 cannot be crossed off. So the square root of 12 is really 2 square roots of 3. 75 is 3 times 25. 25 is 5 times 5. I can cross off 2 5's. That allows me to write a 5. 3 cannot be crossed off, so it's underneath. This is my actual problem. Now here I can subtract them. You can add and subtract if the number underneath the radical matches. You don't change that. What you actually do are combine the numbers in the front. So 2 minus 5 is a negative 3 square roots of 3. Because what you're saying is I have 2 square roots of 3 minus 5 square roots of 3. Well, if you have 2 and you take away 5, you'd have negative 3 square roots of 3. Next one. If you have an index of 3, What that means is when you're breaking apart the number, you need to have 3 of the same value in order to cross it off. Well, 8 is 2 times 4. 4 is 2 times 2. I can cross off 3 2's, and the reason it has to be a 3 is because the index is a 3. So if I can cross off 3 2's, I get to write 1. Now x's, I have 1, 2, 3, 4, 5, 6. So every time you can cross off 3, you get to write 1. Cross off 3, you get to write 1. I don't have any left. Y to the power 4, 1, 2, 3, 4 y's. I can cross off 3, I get to write 1. After I wrote everything out, I just have this lonely y left. So that's what's going to be left underneath. On the outside, I have a 2. I have 2 x's, so that's x squared, a y. Underneath, and remember, this is a cubic root. You have to be really careful to make sure that you remember to write that index. Underneath, I would only have a y. Kind of cool stuff. Next one. These are conjugates. The real number, or my rational number, and my irrational number, my radical, they're the same. But in between, I have one is positive, one is negative. When I FOIL or multiply these, if they are conjugates like we have here, the radical sign should cancel, okay? 5 times 5 is 25. 5 times a negative square root of 5 is negative 5. Oh, sorry, it's square root of x. 5 times a negative square root of x is a negative 5 square root of x. Inside, 5 times the square root of x is a positive 5 square root of x. Last, positive times a negative is a negative. If I take x times x, because the square root of x times the square root of x, you would multiply the two x's together or give you an x squared. A square root and an x cancel each other, so I would just have an x. Now, if I look at the middle, negative 5 square roots of x and a positive 5 square roots of x, they cancel. So I'd have 25 minus x. Or if you're like, hey, that's not standard form, you could write it as negative x plus 25. Okay, so these are some operations you can do with radicals. You can multiply them, you can add them, you can subtract them, you can simplify them, we can even FOIL them. Okay, there are times when a calculator will be helpful to approximate the value of an expression with rational exponents. Let's do that now. Okay, so we're going to go ahead and we want to practice it as roots. So if this is 40 to the 1/5 power, what goes underneath the symbol, what is the radicand is your base. So 40, the denominator of the fraction, that's what kind of index you have. So this is a 5th root of 40. The way that you do this in the calculator, whatever your index is, that's what you're going to type in first. So I want a 5. Now, if you look above the caret symbol, you'll see that they have a radical with a little x there. So I want that. In order to get that little yellow option, I have to hit second caret symbol. Now, what that does is it takes that 5 and it puts it right up there as an index. So this is the 5th root of 40. Notice we have a lot of decimals. It says rounded to the nearest 10 thousandths. So this is the 10th, the 100th, the 1000th, the 10,000th. So I'm rounding it to 4 places. So we have 2.091. When you're rounding it to 4, you have to look at the number after. 7 is larger than 5, so it would bump the 2 up to a 3. Again, that's the 10th, 100th, 1000th. They want us to go to the 10,000ths, meaning you need to round to 4 places. Let's try that again. Whatever the base is, that is your radicand. So in this case, 225 goes underneath the symbol. Whatever the denominator is, that's the index. So what we are calculating is the 11th root of 225. So mathematically, what we're saying is what number times itself 11 times gets you to 225. Let's go ahead and calculate it. You put the index first, so it's 11. Now it's second caret symbol. That 11 carries on up into the x. I want the 11th root of what? 225. We're rounding to the 10,000, so it's 1, 2, 3, 4. After the 4, you look at the next digit. This is a 9, so it would bump that 1 to a 2. So it's 1.6362. So that's how we can go from rational exponents, turn it into nth roots, meaning we write it as a radical, and then we can go ahead and use the calculator. Super cool stuff. All right, let's go ahead and keep going. Now, sometimes you're going to have a numerator that is not a 1. And so what you're going to go ahead and do, whatever the denominator is, that's your index. Okay, so you're taking that root. Then once you've calculated the root, go ahead and take it to the power of whatever that numerator was. So here's an example. Let's say I have 25 to the 3 halves. 25 goes underneath the symbol because that's the base. This is a normal square root because it's an unwritten 2. I would go ahead and calculate the square root of 25. Then you take it to the power of 3. So the square root of 25 is 5. 5 to the power of 3 would be 125. So that's what you do if there's a number other than a 1 on the top. The bottom tells you what kind of root you want. Find that, then take it to the power of whatever the numerator is. Now here are laws of exponents. These you have worked with in Algebra 1 as well as Algebra 2, but it's a really good reminder to just kind of look over those laws and rules. You cannot have the same base mentioned in your final answer more than once. If you have the same base and you're multiplying, what you do is rewrite the base once, you add the exponent. Multiplying goes with adding. If you have one base and it technically has 2 exponents, one inside parentheses, one outside, in order to get rid of the parentheses, you would multiply those together. If you have an exponent outside of parentheses, whether it be side to side or a fraction, that exponent goes to every single thing, whether it be on top or bottom, side to side. If there's an exponent outside of parentheses, bring it into every term. You cannot have a base on both top and bottom, okay? So if I have a base on top and bottom, what you do is write the base. This is division. Division goes with subtraction. So I would take top minus bottom. Now what you need to remember is that when you go ahead and subtract, if you take top minus bottom, if you end up with a negative value, negative exponents go on the bottom. So for example, if I have 5 to the negative power of 2, that's the same as 1 over 5 squared. Negative exponents go on the bottom, and that's what they're trying to show you here. Because 3 minus 5 is a negative 2, so it would be 2 to the power of 2 on the bottom. Okay, so those are the laws of exponents. So we're going to go ahead and step this up a little bit. Now remember, one of the properties says if you have an exponent outside of parentheses, it needs to go to everything. So 8 gets a power of 2/3. R to the 3/4 gets a power of 2/3. S to the negative power of 3 gets an exponent of 2/3. So what I just did here is I took this 2/3 and went to the 8, it went to the R to the 3/4, and it went to the S to the negative power of 3. Now here, this is a cubic root of 8, then you square it, okay? Because the denominator is a 3, so it's the cubic root. What you're asking yourself is what number times itself 3 times gets you to 8? Well, that's 2, because 2 times 2 times 2 is 8. So this has a value of 2. Now you square the 2 to get a 4. Inside exponents, outside exponents. R technically has 2 exponents now, so you multiply them. Remember, when you're multiplying fractions, you can cross-cancel. So this 3 can cross-cancel this 3. So that gives me R to the 2/4. 2 over 4, you can reduce to 1/2. S, same thing here. You would multiply. You could either take top times top, bottom times bottom, and simplify it, or you can cross-cancel. 3 on top, 3 on bottom cancels. So S has a negative 2 over 1, which is just a negative 2. So we went ahead and we combined it to there. Now the directions say we can use only positive exponents. S has a negative exponent. So what I need to do is write it on the bottom as a positive. So I have 4 R to the 1/2 over S to the power of 2. Kind of fun. Okay, so it's taking rules that we have already dealt with before, and we're just going ahead and applying new rules to them and just kind of getting a little bit more advanced, which is kind of cool. What I'm doing here, I can distribute. If you're taking one term times 2 terms, you're actually distributing. So this is what this would look like, guys. So I'd have x to the 1/2 times x to the 3/4 minus, I would have my x to the 1/2 times x to the 3/2. When you're multiplying those, you cannot have the same base. So you write the base once. Because you're multiplying, you add the exponents. So if I'm adding 1/2 plus 3/4, you need to have a common denominator because you're adding fractions. So I need to change this into 2/4 plus 3/4. So this is x to the 5/4 minus, same thing here. You're multiplying two terms that have the same base. So you write the base once, you add the exponents. Here I do have a common denominator of 2. That's awesome. 1 plus 3 is 4. So I can go ahead and simplify that. So we have x to the 5/4 minus x to the power of 2. Now if you look, there's no rule about subtracting the same base. You can't multiply the same base. You can't divide the same base. We can have x to the 5/4 minus x to the power of 2. These are not like terms. They do not have the same exponent. We only have positive exponents, so it's all good. Let's look at the next one. This negative goes to this whole thing. So what we need to realize is on the top, I have x to the 5/2 y to the power of 4. On the bottom, I would have x times y to the 7/4 to the positive 2. By putting this on the bottom, what happens is the negative 2 is shown as a positive. Now we have a property that says this 2 has to go into both things that are in the parenthesis. So the top is x to the 5/2 y to the power of 4. X did not have an exponent, so I'm giving it a 2. So on the bottom, it's x to the power of 2. Here, I have an exponent inside and an exponent outside. So it's top times top, bottom times bottom. So y has 14/4, which is the same as 7/2. Now I have that property that says you cannot have x's on both top and bottom. You can't have y's on both top and bottom. So what I do is I write the x once, top exponent, 5/2 minus bottom exponent, 2. Y's, you cannot have them on top and bottom. So you write the y once, it's top exponent minus bottom exponent. Well, in order to subtract these exponents, you guys, I need a common denominator. So this is like 2/1. So when I'm doing this, this would be 5/2 minus, if I made a common denominator, I'd be multiplying top and bottom by 2, making it 4/2. So x would actually have an exponent. The denominator would be a 2. 5 minus 4 is 1. So I would have x to the 1/2. Y, same thing here. I need a common denominator. This is the same as 4/1. So I would multiply top and bottom by 2, giving this 8/2 minus 7/2. So y would also have a power of 1/2. You could keep it like this. You could go x, y to the 1/2 because they both have a 1/2. Either option is correct.